All right, so here we are, Specialist Year 11, Unit 1, Specialist Maths. So the first bit that we're looking at, as it says up here, is number systems and sets. So the number systems and sets, just some symbols and conventions that are used. So you probably need to refer to these backwards and forwards as we go. Okay, so a couple of handouts, sets and number systems, sets and Venn diagrams. So the sets and number systems, it's this one here. So that's on the website there, Physics with Synno, in that maths page. So it shows you what all the symbols down here on the side here, what all the symbols mean. So if you get stuck, you need to refer to these. Then some Venn diagrams, some sets of numbers, the symbols that are used for real numbers, Q for rational numbers. Z is integers. Sometimes you see J for that, but Z's the accepted convention. Natural numbers, counting numbers, N, and complex numbers, which we'll get to look at a little bit later in this course. Things called complex numbers. All right, so it's kind of a definitions page for you to refer back to if you forget what certain symbols mean. The other one is the sets and the Venn diagrams. Let me go back up to the top here. So the sets and the Venn diagrams. All right, so if you're representing sets of numbers or things in Venn diagrams, these are what the Venn diagrams look like. So again, you can go and you can have a look at those things. All right, so there's all the definitions and some diagrams, 3 sets there. There's some diagrams, all right, of those as well. And then there's another one that I found somewhere for more 3 set kind of stuff. All right, so there's that. So let's have a look at a diagram. An example, I should say. So here we go. Here's an example. Let's go to 100%, shall we? It's better. So here we've got the universal set. That's my funny looking symbol for it. So it's all the numbers 1 to 10. All right. So, and set A is the numbers 1, 2, and 3, and set B is the numbers 1, 2, 9, and 10. So we're asked to do some things. We're asked to illustrate on the Venn diagram and then find these particular things. So if you forget what the symbols mean, go back to your sets and number systems definition page. All right. Meanwhile, whoops, wrong one. There we go. Okay, so let's go first of all, let's illustrate on a Venn diagram. So then once we've illustrated on the Venn diagram, we'll then be able to use that. All right, so let's have a look. So the universal set, so the universal set meaning everything that we're looking at. Well, it's gone a bit funny this morning. Let's have a look again. All right, so the universal set's usually signified by a box, and then put that funny little symbol that I can't draw. And then inside that, in this case we've got 2 sets, so inside that we will draw 2 circles. One of those circles, everything in that would be in set A, and the other circle, everything in that is in set B. All right, so then what we need to do is fill in the symbols. All right, so what I'll do here is change my pen color. Let's go orange. So in set A, we have the numbers 1, 2, and 3. And you'll notice also in set B that we have the numbers 1 and 2. So seeing as they're in both of those sets, we would put those numbers in the overlap. So the numbers 1 and 2 might go in there. So the number 3, it's in set A, but it's not in B as well, so it's got to be out over here. That shows that it's in set A. All right, and now we've allocated all those numbers for those 3 sets. So now we move on to set B. We've already allocated the 1 and the 2 in the middle because they're in both. And now we've got the 9 and the 10, and again they go out over here. They're in set B, but they're not in A, so they're just inside the set B circle. Of course, all of them are inside the box, the rectangle, the universal set. All right, now we've got some other numbers in the universal set, and these other numbers are the numbers 4, 5, 6, 7, and 8. So all of these numbers. All right, those numbers there haven't been allocated because they're not in A or B, or both. So what we do is we put them outside there. So they're part of the universal set, so they've got to be in that box, but they're not in A or B. All right, so now we've got that, we can now write the answers to those questions. And so A union B, so union, the kind of funny looking U, that union means everything can be in A, it can be in B, it can be in both. And so the way we would write that, using that curly bracket, that's the set bracket. So if you're doing sets of numbers, it's that curly bracket's the thing you use. And so anything that's in those circles goes in there. So 1, 2, 3, 9, and 10. All right. Then the upside down U thing, it's kind of like an N with a little without the stroke. That's what's called the intersection. So that's where A and B intersect. So in this case, the things are in both. And the things that are in both are the 1 and the 2. So again, put them in the curly brackets. It's a set of numbers, and that set includes the numbers 1 and 2. Now, I didn't mention before with the union, even though the 1 and the 2 are in both A and B, the intersection, you only list them once. Okay, we don't list these things twice. That's convention. All right, A dashed, so the A dashed is the complement of A, so it means everything that's not in A. So in A, we've got the numbers 1, 2, and 3, so it's everything else. And everything else, whoops, that's not a very good curly bracket, but anyway, everything else is 4, 5, 6, 7, 8, 9, and 10. Okay, so 9 and 10 are listed because they're not in A. All right, and so it's just asking for everything that is in A. All right, so B complement, of course, then, or B dash, was everything not in B, and so 1 and 2 are in B, so we don't put them down. 3, 4, 5, 6, 7, and 8. All right. Let's have a look at the next one. So now we've got some brackets and kind of the BODMAS kind of thing that we've been used to doing with brackets applies here. So it's A union B. So we've got A union B. There it is up there. And then the complement of that. So what that means is that everything that is not in A union B. So everything else other than those numbers. So here we've got our circles. Here, they're A union B. So it's everything else that's not in there, which of course is these numbers here. So 4, 5, 6, 7, and 8. All right, so now this next one, A dashed intersection with B dashed. So this is where our order comes. So up in the previous one, we did our union first, then we took the complement. In this one here, we're taking the complements, then we're looking at the intersection. All right, complement of A, everything outside of A is all of these numbers. So I'm going to get another different colour. All right, so everything that's not in A is these numbers. They're all the ones not in A. All right. Then everything that's not in B. So everything that's not in B is these numbers. Then what it's asking, is it's asking for the intersection of those. So that intersection would be the ones that have got both those marks in there. So the number 4 is not in A, it's also not in B, so it's one of the intersections. So it's 4, 5, 6, 7, and 8. There we go. All right, so you can see when you look at those last two, you can see that their numbers are the same. All right, so sometimes sets could be expressed in a couple of different ways. All right, so one of them's not necessarily any better or righter or more correct, however you want to term it, than the others. You just need to go with be guided with what the question's asking and the question's wanting. All right, so if you want these symbols and things, if you forget what they are, make sure you just go back to your the definitions sheet and refer to that until you kind of get used to what's going on with it. All right, so let's have a look at some other stuff that we can do. It's asking us here to write 3/7 as a decimal. All right, so 3/7 of a decimal. All right, we can do that simply by dividing 3 by 7. And of course, 7 doesn't go into 3. And so now, what do we do now? Well, what we do is we add some zeros here. All right, and we probably can add some more maybe. Let's see. All right, so 7 into 3 doesn't go, and so we've got this 3 left over. We bring up here. 7 into 30, 4 7s are 28, so it goes in 4 times with 2 left over. 7, 2 7s are 14, 3 is 21, so it goes in twice with 6 left over. 60, 7 8s are 56, so it goes in 8 times with 4 left over. And then into 40, 7 goes into 5, 7s are 35. And so it goes in 5 with 5 left over. Into 50, 7 7s are 49 with 1 left over. Goes in there once with 3 left over. Goes into there 4 times with 2 left over. Goes into 20 twice with 6 left over. And then goes into 60 8 times with some more left over. But those of you that are 4 left over will have noticed that when we get to here and then into that 40 that goes 5 times, you will have probably noticed that when we get up to here, yeah, good one. When we get up to there, change my colour. Right, there we go. When we get up to here, these numbers are now starting to repeat. So the convention of what we could do here is that when the pattern starts to repeat, what we do is we write 3/7 equals 0.428571. All right, and then it's those numbers that are going to start to repeat. So what we do to symbolise that they start to repeat is we put dots above the first and last of that group. And so what that indicates is that that group's going to keep repeating. All right, so again, that's something that you need to be aware of and something that we'll be working on. All right, so we can write fractions as decimals. We can also go the other way around, following as a fraction. So let's have a look. Part A is quite straightforward in a way, because 0.05 is, we know that's the tenths, that's the hundredths, so we can say that there's 5 hundredths. And then, of course, the expectation is that we cancel down and 5 goes into itself once and 120 times. All right, so that's not too bad. But what if you've got something like this? We've got some things repeating. So part B is 0.423. And that group is repeating. So if we're going to write it out, 423, 423, 423, and so on. All right, so we can say, I'm going to call that equation number that one's going to be equation number 1. And then what I'm going to do is I'm going to adjust this. Because we've got a group of 3 things that are repeating, what I'm going to do is this. I'm going to multiply both sides. Because I've got 3 digits repeating, so we've got 3 digits repeating. I'm going to times both sides by 1,000. All right, and by the 1,000 because there's 3 zeros. So I'm going to do the multiplication here. I'm just going to go 0.423 times 1,000 on that side. But on this side, what I'm going to do is I'm going to say, all right, so when we, on the right-hand side, multiply that by 1,000, what it's going to do is move our decimal point. So I'm going to get 423.423, 423, and that, of course, repeats. And that equation I'm going to call equation number 2. All right, then what I'm going to do is I'm going to say, okay, if I subtract those, so if I say take equation number 2 and I subtract equation number 1 from it. So the left-hand sides, here I've got 1,000 lots of 0.423 and I forgot my repetition dots. So we've got 1,000 lots of that. Here we've got 1 lot of that. So if I've got 1,000 and I take 1 off, I've now got 900. and 99 lots of 0.423 repeating. That's nice, isn't it? Then when we look over here, I've got 423, 0 here, but then I've got 423, 423, and I've got it all here. And of course that continues. So if I take all of these away from here, then I'm left with 423. All right. So then if I divide both sides by 999, I get 423 repeating equals 423 over 999. And if you check it out, 9 goes into both the top and the bottom here, because this is one I've prepared earlier. I already know that, because you always need to cancel down lowest form. So 9 goes into that 111 times, and 9 goes into 423. You can check it out yourself 47 times. So 0.423 repeating as a fraction is 47 on 111. So there's how we would do that if we wanted to convert back by hand. All right, so some notation. We get onto notation next. And so there's another handout, and here we are. It's this one here, set and interval notation. All right, so some information and then some diagrams down here. So I'm going to work through these things. All right, so some set notation, of course, has these curly brackets and this symbol here. This one's important. The set of what? It's the set of x, such that, what does it mean? It means we've got a set of numbers that are x, and this is what they are. So this one here, x is an element of z, so this one's saying they're integers. Which integers are they? Well, they're the integers between 1 and 5. So they're greater than or equal to 1, but less than or equal to 5. So essentially that's the numbers 1, 2, 3, 4, and 5. All right, just a way of doing it. All right, interval notation you can see down here is different. It's just got some brackets, and then we'll get to the brackets, and I'll talk about those with the examples. All right, so you should have that, and again, it's on the website as well for those who are in Physics with Synno and YouTube land. So let's get back to the question. There we are. Illustrate the following on a number line. So the top one there is what we would call interval notation. So it's an interval of numbers. So should have used the line drawing, but anyway, not to worry. All right, so what do we got here? These numbers are x, and so we've got 0, 2, 4, 6, and there might be more as well. Let's go to 8. It's not. Don't worry about my poor drawing. If you worry about that, you'll go crazy. So what have we got? 2, the number 2. Now you see the square bracket. The square bracket means that the 2's included as well. So these set of numbers between 2 and 6, the 2 is included. The 6 is not. Everything way up to teeny tiny bit less than 6 is included, but 6 itself is not. So the way we do that, something that's included, we use a dot, coloured in, beautiful, like that. Something that's not included, we just have an open circle. And then because everything in between is included, we draw a line. Okay, connecting. All right, again, we've got, for part B, we've got interval notation. Here we are, beautiful. So -2, -4, 2, 4. All right, so we got -3, curved bracket not included, so circle. To infinity, that's up here somewhere, wherever it is, way up there. So what we do to indicate that it's way up there somewhere, you just use an arrow and you point, so like so. And this next one, less than or equal to 4, I'll just do that under here. Let me change my colour, and I'll do it in orange. So see, I'm doing it in orange. Less than or equal to 4, there's 4. Equals, it's included. All right, so the equals, less than or equals. And less than is that way. All right, so we're going down that way, point with an arrow. All right, simple as that. Again, there'll be more of this stuff off and on as we go on, so refer back if you forget things. All right, just conversion between the different notations. All right, so we'll write each of the following in interval notation. So x greater than or equal to 4. So in interval notation, the 4 is included. So if the 4 is included, square bracket. Where does it go to? Well, it keeps going, way, way, way up. So way, way, way up is infinity. Now the convention for infinity or negative infinity is curved bracket. All right, curved bracket, and that's kind of a technical mathematical thing, so, you know, and we can get into that. It's because we don't know precisely where infinity is, essentially, and there's a whole bunch of discussion we could have about that and infinity. Quite interesting. But anyway, that's not for now. All right, so also the other convention is you put the smallest number first. So the number 4 comes before the infinity. All right. Okay, the next one. So between -3 and 3. So, and here, less than. Oh, yeah, -3 is less than x. So the lower number is -3, the higher number is 3. So -3, 3. Because it's less than, the -3 is not included, so curved bracket. Up here, the other end, x is less than or equal to 3, that equals square bracket. All right, the next one. X is an element of R positive real numbers. So R is all the real numbers. R plus is the positive real numbers. R minus is the negative real numbers. And then there's 0. 0 fits into that because it's a number, but it doesn't fit into either of these. So 0 is not considered positive or negative. It's kind of like where you get to the top of the hill, you're on the top of the hill, and then you go down the other side. So, you know, you're going up, you're going down, but when you're at the top, you're not doing either. And that's kind of the analogy. So the real numbers. So the real numbers, what we can say is, well, because it's anything just a smidge bigger than 0 is a positive real number. So I can use 0, but then I can say, well, it's not included. And where am I going to? Well, it's the positive ones. Well, they just get bigger and bigger and bigger and bigger. So again, they're infinity, convention, curved bracket. All right, so there's kind of a little bit of introduction with a few things. So a little bit of practice questions in exercises 2A and B on there. And again, as I said, these will be things that we're using and revisiting all along through. So it's just a little brief introduction to those. All right. As always, have fun.